Alright, so in this video, we will take a look at further examples on how we can apply the special products to expand algebraic expressions itself. Okay, so before we begin, let's write down the three special products that we have. So we have your a plus b the whole thing square is equals to a square plus 2ab plus b square. Okay, continue to say this to yourself so that you can remember it lah. Okay, then we have the second algebraic product. So if let's say I have a minus b the whole thing square, okay, I will have a square minus 2ab plus b square. Okay, and if I have a plus b and a minus b, I will have a square minus b square. Okay, so repeat again a plus b the whole thing square. If I expand this, I'll get a square plus 2ab plus b square. Expand a minus b the whole thing square, I'll get a square minus 2ab plus b square. Expand a plus b, a minus b, I'll get a square minus b square. Okay, or you can also put this as a minus b, a plus b. So either way, it doesn't really matter. Okay, so let's take a look at the first question in level 2. Okay, so we'll go through level 2 questions now. Um, in this case, we have expand each of the following. So 3k plus 2n square and 5c minus 7d square. Now in the first one, 3k plus 2n the whole thing square. You realize that this is basically this form over here. A plus b the whole thing square. Okay, so what we will do is we will rewrite back the question 3k plus 2n the whole thing square. Okay, so when I expand this itself, okay, again recite back, so a plus b the whole thing square, I'll have a square. So as I say out the thing, I'll write down brackets instead of a and b, plus 2ab, so 2 bracket bracket, plus b square, so bracket square. So now I'll fill up the brackets itself. So I have the a as 3k, so 3k and 3k, and then 2n as the second bracket, so 2n and 2n, and then I'll expand them slowly. So 3k the whole thing square, the square will go to both the number and the alphabet. So 3 square is 9, k square is simply k square, plus 2 times 3k, so 2 times 3k is 6k, so 6k times 2n is 12kn. Again, write down your answer in alphabetical order so that you don't confuse yourself. Okay, I repeat 2 times 3k, 6k, 6 times 2, 12, then k times n is kn. And then over here, 2n square, so 2 square is 4, n square is simply n square. Alright, so that's how you expand the algebraic expression using special product, as long as it fulfills these three forms: a plus b square, a minus b square, or a plus b, a minus b. Now let's take a look at the second one. The second one, we have 5c minus 7d square. So you realize that this looks exactly like the second algebraic form. So I have a minus b the whole thing square. Okay, so what we'll do is, again, we will write down everything, um, the question again first. So 5c minus 7d the whole thing square. So 5c minus 7d the whole thing square. So if I expand, I'll have a square minus 2ab plus b square. So I'll rewrite back everything again, but in terms of brackets. So a square minus 2ab plus b square. So your a is 5c and your b is 7d. So 5c, 5c, 7d, and 7d. And then we'll expand them slowly. So 5c square is simply 25c square minus 2 times 5c is 10c. 10 times 7 is 70. C times d is cd. So 70 cd. 7 square is 49. D square is simply d square. So that's how you expand an algebraic expression that is of the form a minus b the whole thing square. All right, let's take a look at the fourth question. Okay, so now it's a bit more complicated because now I have explained and simplified the expression 2x minus 7y squared minus 2x plus y, 2x minus 5y. Realize that it's quite complicated because of the fact that the overall, it doesn't fulfill any of this form. Okay, so instead of scrolling down, let's copy this whole thing first. Give me a moment. Or let's rewrite back the three forms. So let's rewrite back the three algebraic special products. Okay, so I have your a plus b the whole thing square equals to a square plus 2ab plus b square. Then you have your a minus b square. So color change to, I was using green, right? Yep, green. Okay, let's use this. So I have a minus b square equals to a square minus 2ab plus b square. And then I have a plus b, a minus b is equals to a square minus 2a, sorry, a square minus b square. Okay, let's erase this and write this neatly. So a square minus b square. Okay, so let's take a look. You realize that the first one, 2x minus 7y square, is actually of the same form as a minus b square. So this actually follows this form over here. And your 2x plus y, 2x minus y, 5y, is actually of the form a plus b, a minus b. So this actually follows this thing over here. Okay, so I will have to expand them separately first and then combine them together. Okay, so what I will do is, okay, I will expand 2x minus 7y first. So 2x minus 7y, the whole thing square. So again, write down everything in terms of a square minus 2ab plus b square. So a square minus 2ab plus b square. And then I will replace whatever that's inside bracket. Instead of a and b, I'll write down 2x for a and 7y for b. Okay, so expand them. I will have 2 square is 4, x square is x square. 2 times 2x is 4x, 4x times 7y. So 4 times 7 is 28, x times y is xy. Okay, plus 7y square, so plus 49y square. Okay, so I'll just leave this alone first, and then I'll expand the second one, the 2x minus plus 5y, 2x minus 5y. So 2x plus 5y, 2x minus 5y. If I expand this, I'll get a square minus b square. So I'll write down 2x as a and 5y as b. Okay, so 2x is 2 square is 4, x square is x square, minus 5 square is 25, y square is y square. Okay, and then I'll simplify everything, I'll combine them together. Okay, but always remember, put it in brackets. So let's rewrite back everything. So 2x minus 7y, the whole thing square, minus 2x plus 5y, 2x minus 5y. Okay, so 2x minus 7y square is this whole thing. So I'll put it in bracket first still when I'm combining the different workings. So I have 4x square minus 28xy plus 49y square. And then this whole thing minus 2x plus y, 2x minus y is simply this thing. So I will have 4x square minus 25y square. So it's important to put your brackets when you're combining your workings together. Okay, now in front of the first bracket there's nothing, so I can just open up the bracket. I have 4x square minus 28xy plus 49y square. And then over here I can expand everything. So minus times positive 4x square, I will have negative 4x square. Negative multiplied by negative, I have positive, so plus 25y square. Okay, actually this is, wait, the bracket should be outside over here. Okay, and then rearrange the like terms. Okay, so I have 4x square. Okay, this is the first term, so done. Minus 4x square, so minus 4x square. And then next one, minus 28xy. Any more 28xy? There's no more xy, so minus 28xy alone. Plus 49y square plus 25y square. Okay, and then simplifying this, 4x squared minus 4x squared is simply 0. Minus 28xy is alone, so minus 28xy, just rewrite back. And then plus 49y squared plus 25y squared, you will get plus 74y squared. Okay, so this is your answer over here. And then for part B, find the value of expression obtained in A when x equals -4 and y equals 3. So what you need to do is simply substitute x equals to -4, y equals to 3 into, so rewrite back whatever your answer is, -28xy plus 74y square. So I will have -28, so your x is -4, your y is 3, plus 74 bracket 3 square. Okay, and of course you can separate your working, but since it's all numbers, you might as well just type everything into your calculator, okay, with the brackets itself. So you will have 1002. Okay, now is there any way to check your answer? Okay, you can actually sub in this x equals -4, y equals 3 into your original question itself, and you should get back the same answer, 1002. All right, so that's for level 2 itself.